Hello, folks. Thanks for joining us. We're just waiting a little longer for everybody to join. We'll get underway in the next couple minutes. Hello, everyone. Thank you for attending the February edition of our monthly webinar series. Today's topic is playing offense with the domain name system. My name is Emmanuel Yananzadeh. I am the VP of Marketing for Farsight Security. The format for today's webinar is a question and answer session. Our presenters are Dr. Paul Mockapetris, Chief Scientist of ThreatSTOP, and Dr. Paul Vixie, Co-founder, Chairman, and CEO of Farsight Security. More information about our presenters is available online and on the slide shown. Just a little bit of housekeeping. We really encourage audience involvement, so please ask questions during the webinar. In order to ask a question, you can use the question window within the GoToWebinar control. Today we will cover some background information about Dr. Mockapetris and Dr. Vixie. I'm going to refer to the two gentlemen as PVM for Dr. Mockapetris and Paul Vixie for Dr. Vixie. So we'll start with some general information. We'll then dive into the DNS and cover some current hot topics. And then finally, we'll address some questions submitted from the audience. So we have quite a bit to cover today, and we'll just jump into the first question. The first question is for PVM. And so welcome, gentlemen. Thanks for joining.
Happy to be here.
Great. So let me get rid of this. So PVM, how and when did you first meet Paul Vixie?
You know, I'm not sure of the exact circumstance, but you know, the early growth of the internet in the early 1980s was driven by, I think, two big things, one of which was Ethernet and the other one of which was the Berkeley systems distribution, which distributed Unix together with all the networking code around the world. And that really lit the fire then. And one of the things on the BSD distribution was bind. So I think my earliest memory of Paul is that we were talking about how to get more and better bind on the Berkeley distribution tape. That was it. I remember telling him that I felt sorry for the Stanford guys because they had a better implementation than bind early on, but they didn't have the distribution. So sorry, distribution counts, real artist ship, etc. Was that your recollection, Paul?
I certainly remember those conversations, but I also remember our first in-person meeting, which is that you were the chairman of the IETF at the time, and you sent me mail saying that you would like to talk about bind development, DNS in general. And I recognized your name as having been on the RFCs that described the protocol that I was trying to implement. And I thought, well, this probably is not going to be a waste of time. So I remember you flew up from LA or wherever you lived to Redwood City and took me out to lunch, told me the whole story, and invited me to please come to the IETF meeting. The next one was going to be held in Canada. And I remember saying, what's that? And you had to explain. And I guess your problem was that as the chairman of the IETF, you couldn't really be seen speaking because it would be seen maybe as an abusive position. And so you were looking for someone else to sort of come in and, believe it or not, be the voice of reason. And so you are the person who twisted my arm and got me to go to the IETF for the first time. Congratulations.
I'm really good at picking voices of reason.
That's great logic. Guys, Paul, Vixie, beyond DNS, what other interests do you both share?
Well, we both enjoy food, but Paul is much more experienced, PVM is much more experienced at cooking it than I am. And when he chooses a place to live, he actually deliberately chose Paris because I think of the food. So he's probably more of a foodie than I am. But I remember at some birthday party of his, he actually got a famous chef from New Orleans to fly up to Northern California and prepare a multi-course meal for us. It was fantastic. But as far as other interests, somewhere I've got pictures of him standing behind a lawnmower helping me clear brush here in the country. But really, I expect that mostly we share a common interest in this technology. Naming did not have to look like DNS. There were choices, and there are still choices. And a lot of people are exploring this space. If you think about Namecoin or the various distributed hash table-based systems, most of these ideas are bad for reasons that no one other than PVM and I understand. And so we do enjoy sort of picking nits in the proposals as they come up.
Great. So what has been the greatest vulnerability you've worked alongside with each other and to patch it? That's a question for both of you gentlemen. Paul, Vixie, you want to start?
Well, a lot of vulnerabilities that have been called DNS problems are really bind problems. In other words, the spec did not say you ought to be vulnerable to a certain kind of attack. The spec merely assumed that you were going to be reasonable about what you did in the code. And the bind source code that I inherited from the Berkeley Unix project was pretty unreasonable in a lot of ways. So we've seen a number of attacks over the years where you're able to pollute someone else's cache just by including records that they didn't ask for, but that they weren't checking to see if maybe, are you really supposed to be sending me those? Do you own the namespace that those records are part of? Bind didn't care early on. The stub resolver didn't care, the recursive didn't care, just whatever it received, it would then put in. Then there was also famously a bug that was weaponized by Dan Kaminsky, having to do with the shortness of the query ID field and the ability to pollute anybody's cache if you were willing to spend about 10 minutes flooding them with false answers. That also is not something the spec required, so it's not a bug in the spec per se. But we did have to change every name service implementation on the planet in order to cope with it. So I expect that if the specifications that PVM wrote can be called at fault at all, it's that they assumed that all of us were going to be smarter than we turned out to be at how we interpreted and how we implemented.
Yeah, I always explain this as saying, the Wright brothers' first airplane did not have a drink cart or a bathroom. And I think the point was the original DNS specs were to get the thing off the ground. And security was purposely not there. And one of the reasons it was purposely not there was the security community of the time said, we're working on this and there are solutions and we can't tell you everything that's going on, but just listen to us and it'll be good. They sort of say the same thing now, but I digress. I asked NSF way back when about a proposal to add security to the DNS, and they said, nah, isn't really needed. That was in the early 90s. I also was going to try and index all of the internet using a distributed index in the DNS, and they said, nah, it's not possible to index the whole internet. I think that, when you look at the evolution over more than 30 years, what you have to expect is that today's solutions will not be adequate for tomorrow's problems. And what you try and do is to develop solutions or develop capabilities that stay a little bit ahead of the problems. And the only way to do that is to have capabilities that are kind of open-ended. So whenever somebody says, did you imagine all the uses the DNS could have? I said, if I could have, it wouldn't have been a very interesting protocol. I think that, to answer the original question, I think over the years, we've both realized that instead of using the DNS just so that you can locate everything in the internet, you should use the DNS so that you can figure out what's good and what's bad and what's in between, and be able to assign characteristics to all of those names that we created using the original protocols. So I think, ThreatSTOP and Farsight have both been using DNS to distribute security information and to create security information. And I think that's one of the interests that we've shared over the last few years.
Great, thanks, PVM. The next section that we're going to cover is on DNS as a whole. So we'll ask specific questions around DNS. First one to Paul Vixie. How has DNS been weaponized by cyber criminals?
Well, DNS as a protocol is hard to weaponize. It is the governance system around it that has turned out to be a rich source of assets for people who want to attack. So if you consider that, maybe there is some content somewhere on the web, let's say, for example, it's on the web half of the internet, and that content is hurting you. I don't know if maybe it's hosting a copy of your login page for your credit card processing thing that looks exactly like yours, except it isn't yours. And if somebody went there and typed in their credentials, then those credentials would end up on the black market somewhere. Or they could be hosting content that is your intellectual property. There's a whole bunch of different ways that someone on the internet can be doing something that is hurting you. The way we govern DNS is that there is a registry operator, let's say VeriSign for .com or Newstar, I guess, for .info, biz, something like that. Anyway, there are a whole bunch of registries whose job is to make sure that the names people pay for are actually put into the system. Then there are the registrars who are responsible for taking your money and then working with the registry to get that edit made. And then, of course, you have the registrant, the actual holder of the domain name. And then there are various other parties, like, for example, the Whois privacy provider, which tends to be some lawyer somewhere who has the job of preventing recourse against the people who use the internet to abuse others. There are, in other words, a whole lot of different players, and the chances are that if you are being hurt, you can't really get a hold of any of those people. Whois will be hidden, or it'll be junk. The registry will be in a country where you don't have rights. The registrar will be in some other country where you also don't have rights. And so the ability to get that taken down so that it can't hurt you anymore is very limited. And takedown is the probably number one unmitigable risk and cost for people who are online and who are being hurt by other people who are online. And again, that doesn't come from the DNS protocol. This all worked fine before we commercialized and privatized everything. But when we did, we had to build a whole ecosystem of internet governance. And that system is full of ways that you can hurt people without having to pay any penalty for it. So PVM mentioned that both ThreatSTOP and Farsight publish some, various feeds which can be used for defending yourself against this type of attack. And we're still in the early days of it, even though Eric Zegast and I created the first one of these back in 1996. It was called the RBL, Real-Time Black Hole List. That was part of the MAPS company. By the way, MAPS is spam spelled backward, if you didn't think I was clever. And more recently, Vernon Shriver and I put together something called the RPZ, the Response Policy Zone, which is, again, a distributed reputation thing whereby companies such as ThreatSTOP or such as Farsight can publish information that kind of helps you do takedown on your doorstep, because you can't figure out the internet governance system well enough to do takedown on the attacker's doorstep. And these are both things that have evolved to cope with the incredible land rush mentality of everybody who wants all the domains and then they want to use them in all the ways.
Thanks, Paul.
Yeah, in the early days of the internet, we used to say that the value of the internet came from connectivity, and that the more people you connected, the better off you were. And that worked for maybe the first 200 or so. But today, being connected to everybody on the planet, divided by 2 maybe, 3 billion or so endpoints, some of those aren't nice people, and the value isn't there. And similarly, I've only got so many hours in the day to be online. So today, what you really need to be able to do is to figure out how to limit your vulnerabilities and get to talk to the things you want to talk to. I want to figure out how to talk to my bank, and I want to be able to have more of a guarantee that I am actually talking to my bank than I care about when I get random questions from people around the network. So, being able to have that reputation is sort of what we're doing. And, the way that the DNS is weaponized by criminals is we've created all of this connectivity to, there's a billion of us that share connectivity, and some of us aren't good guys. So what we have to do really is today, the problem is to figure out how to limit that connectivity so you aren't connected to as many bad guys as you might be otherwise. There's no end of junk mail that you can get, and there's no end of email junk mail that you can get. So you can't really depend upon filtering it all after you've gotten it. You need to sort of be able to have some reputation up front to help you. And that's sort of what we've done.
Thanks, PVM. So the next question is to you, PVM. To what extent is DNS being used as a data channel, legitimately or illegitimately, as opposed to its original purpose?
Well, again, this is like this question about what was the DNS intended for. It's an open-ended distributed database, and the criminals have found it just as useful as the network scientists have found it useful. So, for example, Farsight and ThreatSTOP both use DNS to distribute security information. There are mobile carriers that use it to distribute information about mobile carrier interconnectivity in ways that the rest of us people never see. There's a lot of private DNS databases that aren't out there. So one of the things that frustrated me back when I was IETF chair was people would run around talking about what's the appropriate thing to put in the DNS. And I always would say, well, DNS is like a truck. You could say it's a 12-foot truck. So anything that's less than 12 feet wide and less than 12 feet long and less than 12 feet tall, I think that's what a 12-foot truck does, put it in there. Sometimes it won't make sense, but it's designed to be a truck and not think too much about, what's inside. One of the early arguments was, well, you can't put any security information in the DNS because you can't trust it, which was exactly backwards in my view. Because sooner or later we found out we were putting all the important information in the DNS, and we hadn't figured out how to put the digital signatures in. Now we've sort of turned full circle, and you can't put anything in the DNS without a digital signature, which is the right way to go. But we probably have some more development to do before DNSSEC becomes as universal as we'd like to see it.
I want to climb onto that answer. So as a distributed database, DNS is really the first of its kind. It's distributed, relatively authentic. It's hierarchical, it's autonomous. You don't need permission from some central authority to make a change to your part of it. And really, there's been nothing like it before or since, and it's a huge achievement. But it can be used not as a database, but as a simple data channel. In other words, That when we are using it to distribute security information, like we've seen some spam from a certain IP address, and this is a way that we can publish that information so that other people receiving mail can check to see if the IP address they're receiving it from is on our list. That's a database. It's not exactly host names and mail exchangers as DNS was originally used for, but it is still a database. But there are plenty of applications that are not that. For example, a video content delivery system will fairly often, as it turns out, have some web server somewhere that is charging your credit card for the movie you want to watch and then sending you a redirect to the actual content server that has that movie. And that redirect is living in the DNS, and it is the query name of the redirect that encodes both who you are and what you are allowed to do. So they're actually using DNS to pass what amounts to an authorization cookie. And I think that's enormously clever. I know Facebook did something like that for the first generation of Facebook Messenger, and it was, again, enormously clever. But then you take the VPN over DNS, which is where you are, maybe you're in a hotel room, a hotel lobby, or a coffee shop, whatever, and you don't want to pay the $5 for wireless. You just want to use it. It turns out that in order to make the paywall, where that Wi-Fi system is asking for your credit card number, in order to make that work, they have to give you working DNS. And once they give you working DNS, you can bypass their paywall and you can fire up some free software. There are many different versions of this that will create an entire virtual private network, a VPN, using only DNS packets. That is not a database. There's nothing like that. There's nothing database-like about that. And that is now used, not commonly, but it has been seen by attackers. Once somebody gets into a corporate network and they've done the lateral move and they've observed and they've done all kinds of work to sort of map out the infrastructure, and they have found your trade secrets and they have found the thing they want to steal, they can't usually get it out using their own control channel because that would set off an alarm. And so we've actually seen them set up a DNS VPN and then just slowly sort of push the data they want to steal out of your network using DNS transactions that don't set off any alarms. So that is, I guess, also it qualifies as enormously clever, but it also is enormously concerning. That is certainly, if there was anything where PVM was ever going to admit that there was something that DNS was not designed to do, he might say it was that.
I've misused tools and I've cracked lobsters with hammers enough time to say that, well, gee, sometimes you just need a blunt force instrument. I must admit, I was surprised to find out that there was actually a Chinese company that was selling software to provide access that underneath the covers was using DNS queries. And we had another Chinese telecom company that was trying to figure out how to turn the first one off because they were sort of using the other company's resources and selling it as a product. Yeah, DNS is a covert channel because DNS goes everywhere in the network. Literally everything in your network can talk DNS, from your cell phone to perhaps your thermostat and on and on. The ability to use it as a channel is slightly ahead of port 80, although port 80 probably still has web traffic. Still is better for bulk.
Thanks, PVM. So the next question is basically our title question for the webinar, and I'd like to have you both address it if possible. We'll start with Paul Vixie. How can organizations play offense against these attacks using DNS?
Well, naturally, I'm glad you asked that because it's what I do for a living. I spent probably 2 decades trying to make DNS work, make it scale, make it cope with commercialization and privatization. And those were exciting times, and I don't regret a moment of it, but I'm not doing that now. I'm now figuring out how to use DNS as a tool to secure other things, rather than trying to figure out how to make DNS itself more secure or more robust or more featureful. And what it ultimately comes down to is using it to make yourself unreachable. So using it as a firewall. In fact, the RPZ system that I developed was probably inspired by unpublished work that PVM had done inside the Nominum company 10 years earlier. And then it was called by Rod Rasmussen, who was then at Internet Identity. It was called a DNS firewall because to him, that's what it was. And that's probably the number one way that you can use DNS to secure other parts of your infrastructure. And what you're doing is you're trying to get differentiated services. You want bad people to get bad service. And the problem with DNS, as it was originally conceived and as it has been crafted, is that it works well. And it works well for everybody. And maybe it doesn't work as well as it should, but it doesn't work worse if you're a bad person. So this DNS firewall idea is meant to address that. It's meant to have it be that if what you're using the internet for is to attack or annoy other people, then they are eventually going to figure out what you do with DNS, what you, the attacker, do with DNS. Where are your name servers? What are they called? Where are your mail servers? What are they called? Where are the fake hosts that are pretending to be a credit card login page? And what are their addresses and name servers? And once somebody can sort of look you up, do some network intelligence, do some detective work, they can simply register the key elements of your DNS resources in a policy filter, which is called RPZ. Although I'm sure that when PVM invented this back at Nominum, he called it something else. But the public one that is now on its way to being a standard is called RPZ. If you put that stuff into RPZ, then you can arrange that none of the bad guys' resources are going to be resolvable by you. If they try and send you email, your mail server will not be able to look up any of the names they were using, and that means it'll probably fail to reach them. Same thing for access to websites. If you know that they are pretty much everything in a certain net block is criminal, and you're going to be receiving URLs and other domain name containing things from them, you might want to make sure that even if your users were to click on that, your customers, your employees, your users, if you're an ISP, were to click on something involving that, it would simply fail. They would just get a normal 404 error in their web browser. They would just get domain not found. And what this relies on is that you can't get anything done on the internet without DNS. And when I say that anything, I mean you can't get any good or any evil done without DNS. Once you put stuff in DNS, then you are subject to all kinds of sort of counteraction by us. And I'm going to come back in a few minutes and talk about passive DNS, which is a database whereby you can sort of do the detective work that I'm talking about. But in terms of the primary offensive tool that uses DNS to secure other things, it would be the DNS firewall called RPZ.
Yeah, I mean, I guess I'd add to that that the first thing that you can do with the DNS in the way of taking the offense to the bad guys is to detect their activity. So when it comes to the covert channels that we talked about, when it comes to botnets wanting to send command and control information, DNS is a very powerful tool for doing these things, and that traffic has, is observable by the good guys. And so what you can do is you can observe it and you can cut it off. Similarly, before you decide to go to a particular website, you might want to decide whether or not that domain name that's part of every web address is a place you want to go or not. More often than not, I think people wouldn't go to a restaurant these days without looking online and trying to decide whether or not it fits. Basically, you should do the same thing before you decide where you want to go. Now, of course, I had a friend of mine who said, I went to this place and it's the one place that would serve me a well-done steak just as I like it. And I would regard that as, I don't ever want to go to that place. The point I'm trying to make here is that very often, whether or not you choose to use a particular piece of reputation information might depend upon your own personal taste. Many years ago, the movie industry wanted to keep you from going to domain names that might have pirated content. While it would have been possible for them to do that, we didn't think the movie industry should be in charge of where you can go. And the ultimate question that comes up here is, whose reputation do you want to take advantage of? So in general, what you want to do is you want to take advantage of security information, because nobody wants to go to malware sites unless you're a malware researcher, perhaps. You want to be able to keep yourself out of the way of harmful stuff, and then you probably want to be able to add your own matters of taste. You may want to not go to porn sites. You may not want to go to gambling sites, and maybe your business wants to do that. So filtering DNS queries in order to inhibit connectivity to undesirable things has been something that's been part of the DNS game for as long as I've been doing DNS. It's just today we're much more sophisticated and you have many more choices about doing it. And being able to do that kind of filtering up front is one of the most inexpensive, from a standpoint, it doesn't cost much in compute cycles or latency or delay or anything like that to do it, and effective first steps. You still need all the antivirus stuff and so forth, but it's the cheapest and most cost-effective defense against malware and content you don't want that's out there. Excuse me.
Great, thanks, PVM. You know, you guys, I have a question from the audience that's relevant to this topic, so I'd like to take it out of turn. So a question from Alan. From an offensive perspective, what type of early indicators can I look at newly registered domains to predict badness? Paul Vixie, maybe you start with that?
Sure. So we've done some studies because we have a global passive DNS network, and we see, I think, a representative sample of the DNS. We have a chance to really start to characterize what it does at Farsight. And so I am in possession of some metrics now that I did not have before we created all of this. For example, first let me just say GoDaddy is a registrar, and I'm going to use them as an example here. If you wanted to buy a domain name, and it was going to be, let's say, paulmockapetris.com, GoDaddy is a registrar. There are a lot of other registrars, but you'd have to go to a registrar like GoDaddy and say, I want this. And if it didn't already exist, then they would say, okay, send us your credit card number and it's yours for a year, and then you have to renew it. Those names are called delegation points because the administration of these, the names above it, in this case .com, is different from the administration of the names below it, which in this case would be PVM. And so that's a delegation of authority, and it is a key point to what makes the DNS so autonomous and so flexible. But those delegation points are created constantly, around the clock. There's always somebody creating one. And I now know a number that I didn't know before, which is that there are approximately 2.5 of those names created every second of every minute of every hour of every day. Now let's talk about longer names. In other words, this is not something you get from GoDaddy, but once you've got paulmockapetris.com and what you want to create is www.paulmockapetris.com, that's not a delegation point. You don't go to GoDaddy for that. You go to your own IT department, or in PVM's case, he edits a config file on his bind server. And so that's a different kind of domain name. It's not a delegation point. That's what we call a fully qualified domain name. And I have a number for that too. We see between 50 and 60 new fully qualified domain names every second of every minute of every hour of every day. There's a third number I'll give you, changes. If www.paulmockapetris.com used to point at this server, but now it points at a different server, different IP address, or maybe it used to point at one, but now you bought a second server, now it's got two records there. That's a change. That's something used to point to one set of records, now it points at a different set of records. I have a number for that. We see that about 600 times a second. Now, there are a lot of other numbers, and I'm just going to stick to those for a moment, because what I want to remind you is these are not absurd numbers for a worldwide network that is used in hundreds of countries by billions of people. This is These numbers seem high to me because I came into this during the academic phase, but it doesn't seem high to me when I consider that the internet is the world's digital nervous system. But I'll tell you something else about these numbers. At least half of them will be dead in a month. And of those half, about half of them will be dead in a day. And of that quarter, about half of them will be dead in a few minutes. And when I say dead, I don't mean that they were taken out of the system. I mean that they've now been listed by Spamhaus or some other network reputation service, so they're not usable anymore. And so they either go out of existence through expiration, or they get taken down, or they get listed in some reputation service. One way or another, these things don't live very long. And so it would not be fair to say that most newly observed domains are malicious. I'm not sure that's false, but that's not the right way to say it because it's misleading. Being new doesn't make you bad. But if you have to guess, and we do in a network this size, we have to guess, it is safe to make that assumption. It is safe to say, if you've never been seen before and I'm seeing you now, I really want to pretend you don't exist for some period, some hold down period, some cooling off period, before I will actually accept you. And certainly when PVM was first working with SRI to set up the original registration system for domain names, SRI used to release new versions of the .com zone twice a week, once on Tuesday, once on Friday. So the idea that somebody could create a domain name and have it worldwide live within 30 seconds was not part of the original set of expectations. And so it's safe, really, to take a new domain and just kind of put it in a penalty box for a little while, because it may be that by the time you let it out of the penalty box, it'll be dead. So we have a system like that. We publish the newly observed domains RPZ feed, which churns once a second. It will send an update to all the customers, adding the delegation points that were created in that second, or first observed in that second, and also deleting the ones that are now older than the time limit you signed up for. At my house, I use 10 minutes. So every second, I get an update from Farsight that says, please add these 3 domains and then delete these that are now older than 10 minutes. That gives me what we call a sliding window. And this is huge. It just means that I'm going to create, if Farsight is wrong, and it is sometimes wrong, where it first observes something and puts it into this list that has existed for months or years, this is just the first time Farsight saw it, right? Our sensor network is great, but it's not perfect. There is no perfect one. And so if we're wrong, there's a false positive, and that'll create a 10-minute outage. But I think we all know by now that anything on the internet can be down for 10 minutes, and is not a big deal. So the false positive cost at 10 minutes interval is low enough that I am willing to just pay it as part of the pleasure I get from knowing that Spamhaus is very fast. They're going to have that thing listed within 5 minutes. And so if it is a spammer and I hold its head underwater for 10 minutes, they probably will die there. And that's okay with me. And then after 10 minutes, they'll come out and then they'll get normal service. That's an example of what I mean by differentiated service. And again, I don't want to say that new domain names are bad. I'm just saying that's a safe assumption if you have to make one.
Great, thanks, Paul Vixie.
Put differently, you could just say, hey, if it takes somebody a day in order for me to be able to talk to them after they've registered the domain name, and that improves my security posture by a lot, I might be willing to take that trade-off, and that's basically what we're doing. There's another approach that says that whenever you see a domain name that's new to you, you're skeptical or more skeptical about it than you are about ones that you've been using for months, days, or years. And these are just heuristics, and frankly, they're the same heuristics that you use when you meet somebody on the street. You meet somebody that you've never met before and they have a wonderful stock market deal for you, you're probably pretty skeptical. It's just adapting to the environment.
Great, thanks, PVM. That's a good analogy with the stock market. So the next question, are IP and domain name blocking redundant, complementary, or something else? PVM, that's directed to you.
Yeah, I mean, everybody's familiar with firewalls, which traditionally have blocked using IP addresses. And the DNS firewall that Paul Vixie's been talking about basically takes a look at a domain name. And today, those things are complementary in that, for example, there's all these people that run content distribution networks that host a mixture of good stuff, malware, and bad stuff. And so you can't filter them just by IP address. There's some exceptions. And I think the world is moving more and more towards names as opposed to addresses as a way to differentiate content. So today, I think what you probably want is both because you probably already have a firewall and it's doing a good job. And if you're filtering by IP addresses, you can do a better job of geo-blocking, in other words, blocking by a geographical distribution, than you can with domain names. Because domain names, although in the early days of the internet, people used to argue that .com was only for the US, I can assure you that today it's not. I remember going to a conference in Germany where there were countries, in particular, the registrar for Iran, that was saying that, well, all of his companies were registering in .com because US customers were more comfortable with that. And, you know, the same thing happens with Israelis that want to sell to Arabs and vice versa. So, you know, you can't really do geo-blocking in the namespace, particularly people can create these aliases. You can do some of that in the IP space, so you may want to. So I think today those are complementary, but I think the blocking by name is ascending in its utility.
Let me pile on here. The name of this DNS firewall that we're discussing is RPZ. It's the response policy zone, not the request policy zone. In other words, although it has the ability to block based on the domain name, that's not very common. It will actually go fetch the answer and learn what the answer would have been, because the answer can also trigger a firewall rule. And so there isn't a necessary distinction between IP address blocking and domain name blocking. You know, if you know that a certain whatever /19 worth of space somewhere in Europe was handed out to a ripe local internet registry that was really a criminal and is going to be full of bad things, yes, you could put that in your firewall and say, look, if a packet comes from there or tries to go to there, drop it. You could do that. The traditional firewall lets you do that. It's just kind of inconvenient to keep it up to date. Whereas in the DNS firewall, what you can say is, if I do a DNS lookup and any of the answers that I get from that lookup are inside that address block, then I want to trigger the policy, which is normally to pretend that it doesn't exist. In other words, return a fake failure. That is more powerful by far. And it's also more flexible by far because there's a publish subscribe mechanism, right? So ThreatSTOP, as an example, or Farsight or Infoblox, there are a number of companies that offer RPZ. Like Spamhaus has an RPZ. They have point source distribution. Their policy comes from somewhere where they're editing it and curating it and publishing, and it goes automatically to all the subscribers. And we've tested this in a lab environment. A single tiny little Raspberry Pi can handle thousands of customers pulling RPZ content for it. And the ability to do that, to kind of outsource the publication and the curation of your policy, and to have that policy cover both names and numbers, you know, IP address numbers, and also name server names would be something else that doesn't show up in the query, but you know by the time you resolved the query what name servers were involved. So maybe one of the name servers that had to be consulted is on the list of things that you don't want to be talking to, or even the name server's IP address block. If you know that every name server in a certain internet service provider is bad, then you can trigger on that. So when we put RPZ together, it was with the knowledge that, you know, RBL back in the day was just IP addresses, and it was only IP addresses as seen by mail servers. and we found that too narrow. Then there was the RHSBL, and I think that came from Jeff Chan of CERBL, but don't quote me on that. But the RHSBL worked only in terms of the domain names used in email, and again, that turned out to be too narrow. But if you do it at the DNS level, and you're able to trigger on both the query name and the answers, the records that are being returned or might be returned, and the name server names and the name server IP addresses, then you really can affect any of the attributes that the attacker could be identified by, and you will affect all of your protocols, because your mail server is only one of many things that should not be talking to that guy. So that's I just wanted to broaden the answer. This is not just about DNS questions, it's about DNS answers and DNS metadata.
Yeah, I mean, it's always been a search to use all of the available pieces of information to piece together an answer. And Paul and I might disagree, because if there's only one bad apple, you don't necessarily need to throw away the whole barrel, although Paul likes to throw away barrels at a time. And I kind of said, well, if you know it's only one bad one, let's save the rest of the apples. So it's still a time of heuristics. It's still a time of extending these things, and we're both working on that.
Thanks, gentlemen. Just a little time check. We're at 47 minutes after the hour. We will go over time, but I'd like to cover the next question, and I'm going to address an audience question, then we'll break into our hot topics. So the next question is also for you, PVM. How do I protect all of my assets connected to the internet, such as IoT, instead of just my mainframes?
Yeah, I mean, in today's enterprise, you typically have at least 4 places where you have resources, one of which might be in the cloud, public or private, one of which is in the traditional enterprise network, one of which is one of your employees sitting in a coffee shop somewhere using their laptop, and the other is your heating, air conditioning, and other systems that you probably don't think are connected to the internet, but probably are. And so the question is, when you defend these, we typically talk about defending the enterprise network. How can you bring these defenses out in a uniform way to all of those 4 different, and maybe there's a 5th or a 6th. And so, you know, at ThreatSTOP, one of the things we do is we use DNS to configure IP firewalls. So we can just do basically a zone or an incremental transfer and change all the rules in your firewall about IP blocking instantaneously, while we're in parallel using RPZ to change your bind servers and using other mechanisms for other defensive things. One of the things we've been doing lately is running a full DNS server in your laptop. No offense, but your laptop is today much more powerful than the original root server computers that we had in the internet. And you can run a whole DNS server and run a DNS firewall customized to you in your laptop. And furthermore, you don't need what I used to refer to as a white lab coat or the ability to compile bind. You can just download it and test it from the ThreatSTOP website. Some other people have similar technologies. But I mean, one of the things we've struggled to do in ThreatSTOP is to use the DNS to program both IP blocking and DNS blocking, all the way from your laptop to your firewalls to the virtual firewalls and virtual DNS servers in your cloud, and down to a server that could protect your infrastructure of air conditioning and so forth. I worked for a while in the DoD, and one of the things is that the hardware there, you know, B-52s are going to be flying for almost 100 years. And a lot of the computers are almost as old. And when you say you got to protect them by downloading the latest software patches, well, nobody has the source code anymore, and nobody hasn't made a release. If you have digital devices, and you may say, well, I don't have B-52s, but you may well have ATM machines that are based upon XP or things of that ilk. If you want to figure out how to defend those, you should be wrapping a layer of IP blocking and DNS blocking around them, which is easy enough to do because you can even implement this stuff on a Raspberry Pi. So being able to think about a consistent protection across the perimeter of your enterprise, where it comes in many different places, is one of the things that's necessary to do, as well as protect devices that just can't protect themselves.
That's great, PVM. That's very valuable. Thank you. So I want to take this out of turn, you guys. We have a question from Paul Keating. and basically he's asking, what do you think the impact of GDPR will be on DNS vis-a-vis restrictions on accessing who is? Maybe we start with Paul Vixie.
So GDPR is this year's boogeyman. It is kind of like Y2K. A lot of people are selling a lot of consulting and books and training on this topic. And it is a big deal for anybody who has been kind of fast and loose with other people's personally identifiable information. But I think that as it settles in, as it comes in and lands, it's going to get fine-tuned, and some of the interpretation questions will inevitably have to be settled in court. Now, we have some colleagues over at a company called Domain Tools, who is very big in the who is business. They have an API. They've got a great web user interface for it called Iris. And they have, because this is near and dear to their hearts, they've done a lot of study. And it turns out that it is, there's nuance here, because what you can collect and what you can share and what you can retain depends in part on your intent. And so the intent, if your intent is commercial, if what you want to do is spam people, there are things you can't do. But if what you're trying to do is to protect people or protect your customers or protect yourself, and you're not going to be using this information in a way that is, annoying to the people whose information it is, then chances are you will still be allowed to do it. So, my own thinking is GDPR is a good thing. It's kind of a subset of what they've been doing in Germany for years now. So just as the euro is really the old Deutsche Mark, the GDPR really is the old German privacy law, and they take this stuff seriously, and they have really put a lot of thought into this. And there are plenty of American companies, internet companies, who are screaming bloody murder because they won't be able to monetize privacy anymore. Well, that's okay with me. And so I really think that the who is going to get solved. I don't think we're going to go dark. I'm not sure exactly what form it's going to take, and there will have to be changes, and there's a lot of awareness that will have to filter in where ignorance exists today. But I really don't think we should be running down the hall with our hair on fire because of GDPR.
Yeah, I think people used to talk about how the internet changes everything, and then there's Newton's, I think it's second law, about for every action there's an equal and opposite reaction. I think that the internet may have changed everything, but everything is now pushing back on the internet in particular ways. And we've seen the same question about, well, okay, if data about U.S. People is held by a U.S. company, but outside of the U.S., what legal restrictions are there on who can access it, and vice versa. So I think people, and having lived in France for 8 years and seen this, a lot of the ways that the different European domains regulate the internet is refreshing, although not quite as Howard Rourke-like as you might like. So I think that these regulations will go back and forth. I think that the who is thing is a tempest in a teapot, because people can register domain names and keep themselves anonymous using shell corporations in Liechtenstein and blah, 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 blah. It just costs a little bit. The GDPR rules, it's not going to change the way domain names are used. It'll just make it a little bit more difficult to do some of the forensics. I think the real issue is going to be, well, if I take my cell phone to Europe, is the data that's created in my cell phone in Europe not allowed to go back into the US? Or, I think those kinds of things about how data is shared and who controls access to it are the really important issues that are going to get worked out. And who owns a domain name? Not so much.
Great, thanks, gentlemen. So the next section we're going to go into are what we're going to call hot topics. These are just 5-minute quick takes about the role of DNS on the given topic. So these are directed to both of you. We'll start the first one with PVM. Blockchain and Bitcoin, how does what is its role to DNS and what is its impact?
I think to date, it's been small. People have proposed things like Namecoin and so forth. I myself thought, well, gee, what we could do is we could just make an algorithmic registrar system where we don't need to have all of these people collecting their tolls, and we could just have a well-known set of rules about who can register in a particular domain and just automate all of that. I still think that would be a good idea, but the people who are the gatekeepers didn't really like it that much. I think implementing distributed ledgers and perhaps as far as a blockchain kind of thing as part of the DNS protocol is another interesting idea, but it hasn't quite come yet.
Thanks, PVM. Paul, Vixie, you want to add any to that, or?
Well, you mentioned blockchain and Bitcoin. I want to say that Bitcoin is an example of cryptocurrency, and there are many others, Ethereum and so on. And their role in human history is still being decided. It turns out fiat currency, where you print more money if your nation needs a greater money supply, is a legitimate tool of statecraft. It isn't just abused by greedy or stupid people. And I think we're going to see a regulatory regime around cryptocurrency that will preserve the role of governments in controlling the money supply. And you can quote me on that if you want. We'll know in a few years. Whereas blockchain is a really cool thing. The ability to do micro contracts or have secure medical records, or the ability to basically sign something using a key that is all that went before, so that you have an indelible ledger that is shared by many people. There are some problems that are going to be worked out about transaction scale. How many people can be adding to it? How many copies of the ledger can you keep up to date? That kind of thing. But those are science problems. Those are not rocket science problems. So there have been a couple of efforts now to use this for naming, and at the moment they're all solutions in search of a problem, because although there are many people who are not happy with the current internet governance model, there are a lot of people who are happy, and so there isn't really a market for replacing it right now. So I currently do not think that we're going to be seeing any blockchain-like replacement for DNS getting any commercial traction, because what we have is not hurting anybody bad enough to warrant the replacement cost.
Great, thanks. The next question, again, as it pertains to DNS, we'll start with PVM, artificial intelligence and machine learning.
Yeah, I mean, people are always trying to figure out how to draw conclusions from the data. And I think that once it goes from a program that's not compiled into something that's more flexible, we call it AI. So, this has always been the part of any sophisticated effort to analyze data, because there's just so much of it that having to have an algorithm that's adaptive is pretty much imperative. So, yeah, it's just a fact of life.
Well, my view on AI, which is what they used to call it, and they're calling it again, deep learning, which is what they called machine learning after they realized that having humans find features was a scaling problem, is that every one of them is an interesting buzzword, like blockchain. There was a period of time where you would get automatically funded no matter how shaky your idea was if you said you were going to do machine learning. And the same with blockchain. Then the time eventually comes when you will automatically not get funded, no matter how good your idea might be, if you mention machine learning or someday blockchain. So these things come into vogue, they go out of vogue. But in terms of their real utility, I agree with PVM. There are some very subtle conclusions that we would like to be able to come to about this enormous trove of data, about what's in the DNS, how it's being used. And these as data analytics techniques for data scientists, they make a lot of sense. But there's always a hype component, and if you read this closely, what you'll hear in a lot of pitches is, we won't understand why we gave you that answer, and that's a feature. And if somebody says that, you need to, keep your hand on your wallet.
Great.
Yeah, I prefer the little Stevie Wonder rule: is when you believe in things you don't understand them.
Okay, the next one is a thick one, so if we could keep it concise. I don't know if this is possible, but I'll throw it out there. Election integrity as it pertains to DNS.
I'm not sure how it pertains to the DNS, but I think everybody has a history of trying to change everybody else's elections, and it's gone on for millennia. And we need to be aware of it, and we need to try and correct for it, and that's about it.
So there is a tie-in, and it has to do with credibility. There was a time when we had a joke, which was, I read it on the internet, so it must be true. And that was that when that joke started being funny was after a lot of people for a long time had said, but I went to a website that had whatever John McCain in its name, therefore it must have been him speaking. Eventually you start to realize that pretty much anybody can create a domain name that says pretty much anything, and you should not look at the name of the domain that is in your browser bar, whatever you've been asked to click on, whatever you found in the search engine. Don't look at that and say that it must be authentic, otherwise the domain could not have been crafted, because that's just not true. Anybody can craft a domain name that looks like anything. And we have at Farsight a brand protection feed where you register your trademarks with us, and we will look for those in all of our feeds to find out if your name is being used in some way that you didn't expect. Some brands are better than others. A particularly terrible brand is Las Vegas, because it appears everywhere, right? Las Vegas is almost a generic term. And so the city of Las Vegas does not really have any particular claim on it. And there's an awful lot of things that have Las Vegas in the name that are not related to Las Vegas. So that makes it a bad brand as far as trying to protect it. But I want to say that there was a mass shooting there last year, a very tragic event, very upsetting to me. And so I registered the Las Vegas trademark with our domain protection service, and I just let it spam me all day, telling me about all the false positives, all the different things that had Las Vegas in the name. And I let it go on for about 2 weeks because that was my way of grieving. And in that 2 weeks, I pretty much followed up on every lead with a web browser, with DNS database, with Whois, to try and find out if there was anybody who was trying to capitalize on the tragedy. And there were two. There were two different sites that popped into existence and said, we are a victims fund. If you give us your credit card number, and we will start paying for hospital bills and all the rest. Now, experienced people in the ways of the world know that that is probably not true. Just because somebody wants to sell you the Brooklyn Bridge doesn't mean it's theirs or that it could be yours. Nevertheless, a lot of people are taken in by these things. And yes, I reported both of these. And it turns out every tragedy, every news event has this. And it turns out that there are an awful lot of fake websites that pretend to speak for some candidate or some party or some cause whose real job is to make it look bad or to change people's mind. And unfortunately, the DNS still has a connotation of authority that it does not deserve. Because again, anybody can create a website whose name is anything. And the only way you can really know whether it's really affiliated with the brand name that it's using is to look at it and to look at its whois, and look at its name servers, look at its history. And that is more work than most people can do. So I think that in the 2018 election and again in the 2020 presidential election, we're going to see a mammoth influx of fake content, and that will all be trying to use domain names as one of its powers of credibility. And I don't know how to get the word out that most of this stuff is crud.
Thanks, Paul. We have a question from the audience. Let me just break this out. With Let's Encrypt now doing, quote, good things, unquote, with certificates, particularly regular renewals, is DANE, D-A-N-E, likely to become more of a thing? There's a lot of potential there. That's from John Howler. Does that ring anything for you guys?
Sure. I mean, this is, you start with DNSSEC and then you build DANE, and Let's Encrypt and certificates and so forth. One of the things about security is that it's always been expensive in terms of the resources you need to implement it, and the fact that it makes it a little bit harder to go to legitimate places. It's just kind of a drag on your activities. And so one of the important things, I think, is to figure out how to have certificate mechanisms and encryption and so forth at a very low cost to the user, because if it's expensive, the user won't use it. The cost of security from a standpoint of inconvenience, as well as just real costs of latency and delay and so forth, figuring out how to give you security in a way that's understandable and cheap is the imperative in my view. And DANE and and Let's Encrypt and so forth are efforts along that way. But I think that we're going to find that we probably need a second or third generation before we really start to see the benefits. Right now, it's mostly for people with the white lab coats. DNSSEC may be being reduced to being something that you can use every day, or more accurately, you can have your provider implement for you without having too much pain. So it's on the way, but it's not here.
I want to tell two PVM stories about all this, and then say what I think. So X509, which is the certificate system that underlies TLS and SSL, is the thing that Let's Encrypt is doing. It's the thing that web browsers look for and that web servers offer, is really not good. There's a lot wrong with it. The fact that you can create something like Let's Encrypt shows one of the things that's wrong with it. But anyway, during one of my earliest meetings with Dr. Mockapetris here, I complained about this because he was the IETF chairman at the time that the IETF rubber stamped this particularly bad idea. And he told me that it was distinctive by not being as bad as all the other proposals. But I just want to say I still think that we should have had better. And the second PVM story I'll tell is about DNSSEC, where we sat down to lunch one day after DNSSEC had reached some standardization milestone, and he said, "You guys did it all wrong. If we don't have security going all the way down to the stub resolver, so that the application can validate the signatures itself rather than trusting that DNS has validated the signatures for it, then you're never going to be able to do true end-to-end security." And he was right. And we've been working on that. They're trying to figure out a way to get the signatures all the way into the web browser so that it knows whether to trust those DANE key signatures or not, is hard, because the metadata signaling that you need to carry DNSSEC is often not permitted through corporate firewalls or coffee shop firewalls or what have you. And so you end up with DANE, you're essentially trusting the coffee shop to introduce you to your own bank. And that's a really bad security design. And, I'd like to see that fixed, but I want to point out that I have archives of DNSSEC discussions going back 22 years. And we were arguing about some of this stuff then. And I don't think that this team on this track is going to be able to solve this problem. And so I'm looking at Let's Encrypt as kind of an interim solution that's likely to have to last forever. And it's a good thing that it was well designed, because I don't think that we're going to be able to make DNSSEC ubiquitous to the places that all the validation would like to occur, which is the endpoints. And I do think that we're going to be able to make Let's Encrypt ubiquitous. And so, you know, I am cautiously optimistic that somebody else solved this problem for us. I'm cautiously pessimistic about what does that mean for the incredible investment in DNSSEC over the past two decades. If we couldn't solve this problem, what the heck did we think we were getting for it? But that's probably a discussion for a different day.
I think it's important to realize that there's probably, 5 years of good work in that 22-year history. Anyway, let's move on.
Great. All right, guys, we're going to get to the last question of the day. And it is also going to be for, actually, this is for Dr. Vixie, of course, PVM. Feel free to chime in. How are ThreatSTOP and Farsight collaborating to combat cyber criminals? Anything new on the horizon?
Whew. Well, there's all kinds of new stuff that we're still talking about. And then there's usually new stuff that we haven't talked about yet that, I always have to wait for the right quiet moment to bring up, because what I want to do is always controversial. But, what we're doing right now, besides sharing PVM, he is ThreatSTOP's chief scientist. He is also the other half of the Farsight board of directors. We're doing a bunch of RPZ related things together. They have something down at ThreatSTOP that I jokingly refer to as the blender, that creates a bespoke RPZ combination feed for customers based on sort of they get to pick and choose from a catalog. What RPZ ingredients do they want, and then they get one made just for them that has exactly what they want. And it's a very interesting system, and it does work. It really supports that laptop case very well. And we have our own desires around RPZ futures that in some cases we punt to ThreatSTOP because they're already solving that part of the problem. And in some cases they punt to us because we're already solving that part of the problem. So I very much consider Tom Burns and the rest of the staff there to be fellow travelers. And I have for years, even before we started working together as Farsight.
Great,
yeah, I think
thanks,
one
Paul.
of the more interesting things to do is to run your own DNS server in your laptop. Now, of course, all the IETF people will come along and explain to you about how it doesn't scale, and it's going to destroy the whole internet and so forth and so on. Well, maybe it's time to move fast and break things. If I want end-to-end protection, I can run my own DNS server. Now, it may be that I'm going to have to figure out how to change some of the ways that I do business in order to make this all scale. Like, for example, distributing copies of the root zone rather than relying on the root server cabal. It may be that being able to move into your machine and get end-to-end protection is going to be worth the stress that you're going to cause and the mechanisms that are going to have to be put into place to resolve that. I think the other thing to realize is that in general in security, most of the smart things that you need to do are best outsourced unless you're a large organization. And so what places like ThreatSTOP and Farsight, which are dedicated to outsourcing those kind of functions for you, we need to have our feet kept to the fire in order to make it easy for you to use. So we're always interested in hearing from the audience because not everybody's going to run their own passive DNS. Not everybody is going to run their own blender where we take a look at about 100 different sources every day to decide how to construct thousands of different block lists for different customers and their geo-blocking preferences, or whether or not they care to block different kinds of potential threats. But is that answering your outsourced needs to provide better, more cost-effective security? I think that ease of use and scaling are the other challenges. So
let me talk to the scaling question. If it is a matter of faith among people who don't study DNS for a living, that we have to share a cache among a large population in order for it to be effective. It's an article of faith for other people who have not studied it to say that caching itself is not necessary because the internet's fast now. And they're both wrong. It turns out that if you don't have any caches at all, then there is not enough electric power in the universe for VeriSign to run .com. It wouldn't matter how much they spent on it. But if you have caches everywhere and none of them are shared, everything scales just fine. So a personal DNS server does not create a scaling headache, because the queries that you want to suppress are the ones that your applications are stupidly making over and over again, not the ones that other people living in your house also make, right? One of those is a fixed parameter, one of them is a variable parameter. So I am a big fan of running your own recursive. I have one in my laptop. It's not the one from ThreatSTOP, but I do have one. And I use it all over the world, and I'm not putting undue load on anything by doing that. I do want to say that there are some pretty good systems out there. Google has a name server 8.8.8.8, and now IBM has one called 9.9.9.9. Several of us have joked we may need to make 10.10.10.10 now. Then there's OpenDNS, which is, I guess, now called Umbrella. It's part of Cisco. Their addresses are not memorable, but they operate, open recursive name servers for the world. All of those are credible. They're all trusted. You should not worry that they're going to do bad things with your privacy if you let them see your data. And frankly, your ISP might actually do bad data mining commercial things with your data if you use the ISP's name server. So it's really not a bad idea to use one of those, but you'll be much better off if you just run your own. And you can run it on a Raspberry Pi using a bunch of whatever Linux packages that you download. You can get one going in half an hour if you have a lab coat. Or you can get the ThreatSTOP solution and run it in every laptop. And if you do that, you will have far more control over who sees what you're doing and what security controls you're going to have. So that's actually one of my big pushes this year, is to get people to start understanding that the original use case, the original way that Bind was used to implement DNS, was that every LAN had a name server and everybody just used that one. We didn't need OpenDNS or Google or IBM to run a name server for us. This used to be something everybody did for themselves, and it's pretty easy. So I'll end there.
Great, thanks. Actually, gentlemen, we got two more questions, so let's just keep going here. The first one is, how does DNS control deep web, dark web, main cyber threats in large scales? Let's start with PVM on that one.
I mean, DNS doesn't, is the answer. DNS is a resource that's used by bad guys everywhere. But, they also understand that we're looking for them. So they will also try and avoid being detected. And so a lot of the bad guys are trying to figure out how to avoid, being seen. I've run with the foxes and I've run with the hounds. I once upon a time worked on what we used to call low probability of intercept transactions across the internet. Good guys are interested in doing that to keep censorship and to keep political repression out of the equation. But the same techniques are used by the bad guys. So life goes on.
Great.
So there's a DNS layer inside of the onion router, Tor. And certainly a fair amount of what was called the Silk Road when it existed and what is called the dark web now are reachable using fixed identifiers going through the Tor system. And that's much more a peer-to-peer thing. It's not a universal system like DNS is. And there's a huge overlap between the blockchain people and the dark web people, right? Because if you don't want, let's say, the government or your ISP to be able to take down something, you need to put it out of their hands. You need to make sure that none of the proofs go through equipment they control. And so to the extent that there are criminals out there that want to use this stuff and they don't want to be stopped, they are very interested in the future of blockchain for DNS-like features. And as PVM says, DNS itself is a public system. You can make private systems that are unreachable, but you need an IP firewall to make that so. And so generally, DNS is used for things that you want the world to know, and that just makes it a poor fit for dark web use.
Okay, the last question, guys. We'll address this to Paul Vixie. Interested in your thoughts on xproxied 4. It seems like it could be very useful if using something like DNS dist in front of resolvers and maintaining ACLs.
You have stumped the band. I don't know xproxied 4, but I'm going to be Googling it right after this call.
John Houtler, would you like to expand on that question? Let's see if we get anything on that. Okay, we'll follow up anyway after. Oh, we do. We have. He will follow up. 1 second. We'll get you a question. So actually, let's take that offline, John. So, gentlemen, I want to thank you for putting a. Yeah. We will take that question offline. Sorry. So I want to thank both of you for making the great effort of today, although you're both feeling quite under the weather, so I really appreciate it. And so that pretty much concludes our program today. I hope everyone enjoyed our webinar today, and we will make it available on demand in the next couple of days, and as well as a transcript, and you can distribute it to your friends and colleagues. For more information about Farsight and ThreatSTOP, please visit threatstop.com and farsightsecurity.com. And if you have any other questions, you can forward them to this chat, and we will address them after the session today. Thank you very much, and have a good day, everyone.